let's have a look at question 5 of this paper. It's a projectile question. Let's have a look. A small ball is projected with speed 28 meters per second from a point O on the horizontal ground. So straight away we can resolve this. One in the vertical direction, that would be 28 sine alpha. And the other one is the horizontal direction, that would be 28 cos alpha. And then after moving for t seconds, the ball passes through the point A. So when the particle reaches point A, time is capital T. And then point A is 40 meter horizontally and 20 meter vertically from point O, which I already labeled it here. The motion of the ball from O to A is modeled as that of a particle moving freely under gravity. And then given that the ball is projected at an angle alpha to the ground, use the model to show that t equal to 10/7 cos alpha. Okay, so like before, we just set up two equations, one in the vertical direction, the other one in the horizontal direction. So let's start from the horizontal first. So for the horizontal direction, we have initial velocity u equal to 28 cos alpha, and then time is capital T, and then displacement is 40 meters. So because in the horizontal direction is constant velocity, so you can just do s 40 is equal to velocity times time. So rearrange that, t is just equal to 40 divided by 28 cos alpha. So simplify that, it should give us the answer straight away. 40/28 is 10/7. So that's just 10/7 cos alpha, which is what we want. And then part B, show that 10 square alpha minus 4 tan alpha plus 3 equal to 0. So now we should use the vertical direction. So for the vertical direction, we have u is equal to 28 sine alpha, and then time is still capital T, and then this time we need to use acceleration, and since it's projected upwards, so it's again the gravity, so A should be negative g, and then as the displacement is equal to 20 meters, so we should use s equal to ut plus half at squared. So s is 20, u is 28 sine alpha, t is capital T, and then plus half times a negative g, which is negative 1/2 g, times by t squared. So simplify that, we have it's really not much to simplify. So we can just substitute our t from before into this equation. So 20 equal to 28 sine alpha times by 10/7 cos alpha, and then minus 1/2 g, and then t is equal to 10/7 cos alpha, and then square that. So simplify this, 20 equal to, so 28 divided by 7, so that would be just 4, and then 4 times 10 is 40. And then sine over cos is 10, so that would be 40 tan alpha. And then minus half times by g is just 9.8 times 0.5, which is 4.9. And then square both top and bottom of the fraction, that would be 100/49 cos square alpha. So 20 equal to 40 tan alpha minus 4.9 times 100 divided by 49. That will give us 10. So that would be 10/cos square alpha. And then we can divide by 10 for both sides. So 2 equal to 4 tan alpha, and the minus, so 1/cos square alpha is just equal to sec square alpha. And then we know there's one identity can change sec square alpha into tan square alpha, which is 1 plus tan square alpha equal to sec square. So now simplify that, we have 2 equal to 4 tan alpha minus 1 minus tan square alpha. Now move everything to the other side. So plus 10 square alpha for both sides, minus 4 tan alpha for both sides, and plus 1 for both sides. Then that would be what we want. Yeah. Okay, part C, we want to find the greatest possible height in meters of the ball above the ground as the ball moves from OTA. So basically, we're looking for what's the greatest possible height above the ground. So we're looking for what's this height. So for this one, we know when the particle reaches the greatest height, velocity has to be equal to 0. So again, we use the vertical component. U equal to 28 sine alpha as before, and then V equal to 0, and then A is negative G, and then the displacement is what we're looking for. Yeah, so it has to be V square equal to U square plus 2AS. So what we know from here is we know V equal to 0, so we put in 0. And then we know U is 28 sine alpha, and then square that. And then plus 2 times A, so that would be negative 2G times by S. So that means 2GS is equal to 28 square is equal to 784 sine square alpha. So S is just equal to 784 divided by 2 divided by 9.8, which is 40. So as long as we know what sine square alpha is, we can work out the answer. So we can work out sine square alpha from what we get before. So solve this equation. We have tan alpha minus 3, tan alpha minus 1 equal to 0. Because negative 3, negative 1 give you 3, and then negative 3 plus negative 1 give you negative 4. That's how we factorize this. So tan alpha equal to 3, or tan alpha equal to 1. So then I will just draw a little triangle like this. So if this is alpha, tan alpha is opposite over adjacent, so that would be 3 over 1. Then the hypotenuse has to be square root of 3 square 9 plus 1 square 1, so that would be root 10. So from here, we know sine alpha equal to 3 over root 10. And then from this one, we know, so 1 1, that would be root 2. So sine alpha equal to 1 over root 2. So now we just have to substitute in to work it out. So if sine alpha is equal to 3 over root 10, then we have S is equal to 40 times by 3 over root 10 square. And then put in the calculator, 40 times by 3 over root 10 square. That would just equal to 36 meters. And then if sine alpha equal to 1 over root 2, then S is equal to 40 times by 1 over root 2 square, which is equal to 20. So obviously this is bigger. So the greatest possible height above the ground would be 36 meters. Yeah. And then for the last part, the model does not include air resistance. State one other limitation of the model. So really just like what we did before, always say the same thing against them. So for example, they say like they model the ball as a particle, you can say the dimension of the ball or the spin of the ball. And you can always say my more accurate value of G, something like this should be fine. Yeah. So I will just write dimension of the ball. Then that'll be the answer for this question.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.